Our lesson for today is all about applying the theorems to show that given triangles are similar. For our first activity, let's identify the theorem used in each figure. I will give you 1 minute to answer the following figure. Time's up. So now, let's check your answer. For number 1, the answer in number 1 is right triangle similarity theorem. For number 2, we have the special RTT or the special right triangle theorem. For number 3, we have the SSS congruence postulate. And for number 4, we have the SAS. And for number 5, we have the AA. Next, in the previous activity, we encounter a situation wherein you identify theorems for similarity of triangles. Let us continue the discussion by having a recall of these theorems. Before we apply these theorems, it is better for you to be reminded about these theorems. For our first theorem, we have the SAS similarity theorem. Two triangles are similar if an angle of one triangle is congruent to an angle of another triangle, and the corresponding sides including those angles are in proportion. Next, the SSS similarity theorem. Two triangles are similar if the corresponding sides of two triangles are in proportion. Next, we have the AA similarity theorem. Two triangles are similar if two angles of one triangle are congruent to two angles of another triangle. Next, we have the right triangle similarity theorem. If the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. Next, we have what we call the special right triangle theorem. In a 45 by 45 by 90 degrees triangle, each leg or L is the square root of 2 over 2 times the hypotenuse or h, and the hypotenuse is the square root of 2 times each leg. While in a 30 by 60 by 90 degrees triangle, the shorter leg or s is 1/2 the hypotenuse or h, or square root of 3 over 3 times the longer leg, and the longer leg is the square root of 3 times the shorter leg, and the hypotenuse is twice the shorter leg. Now, let us take a look at the following examples using SAS, SSS, and AA similarity theorem. For our first example, let's find the length at the unknown side or the measure of the unknown angle to make each pair of triangles similar. For number 1, we have by SAS similarity theorem. So for number 1, we need to find the value of x. So for our solution, we will have 4 over 16 is equal to 7 over x. And we're going to apply the fundamental rule of proportion. So therefore, we have 4x or 4 times x is equal to 7 times 16. And 4 times x, we have 4x. And 7 times 16, we have 112. And after that, we're going to apply the multiplication property of equality. So we're going to multiply both sides by 1/4. So therefore, we have 4x times 1/4, we have 4x over 4. And 112 times 1/4, we have 112 over 4. Next, 4x over 4, we have x, and 112 divided by 4, we have 28. So therefore, the value of our x is 28. Next, by SSS similarity theorem, given the two triangles, we're going to find the value of b. So for our solution, let's get the proportion of b over 30 is equal to 12 over 36. Or you can use b over 30 is equal to 8 over 24. It's up to you, class, if which among the two are you going to use. So for this example, we're going to use the first one. So let's apply the fundamental rule of proportion. So we have now 36 times b is equal to 30 times 12. So 36 times b, we have 36b. And 30 times 12, we have 360. So therefore, we have 36b is equal to 360. And after that, let's apply the multiplication property of equality. So we're going to multiply both sides by 1 over 36. So we have 36b times 1 over 36, we have 36b over 36. And 360 times 1 over 36, we have 360 over 36. So 36b divided by 36, we have 1b or b. And 360 divided by 36, we have 10. So therefore, the value of our b is equal to 10. Next, by AA similarity theorem, so we have a given triangle, we have a given angle which is 40 degrees. And another given angle or degree measure of angle, we have 90 degrees. So we need to remember that the sum of angles of a triangle is equal to 180 degrees. So therefore, what will be the degree measure of the remaining angle? So the answer is 50 degrees. Since we're looking for the value of x and we have a vertical angle, we all know that the vertical angles are congruent. So the opposite angle of 50 degrees, the degree measure of that also is 50 degrees. And since there is again a 90 degrees triangle, 90 degrees angle in another triangle, so what will be the value of x? That's right, the answer is also 40 degrees. Now, let's proceed to the right triangle similarity theorem. Consider triangle ABC such that angle C is right angle and line segment CD is an altitude to the hypotenuse. We proved on the previous lesson the triangle ADC is similar to triangle ACB and similar to triangle CDB using the similarities in right triangle. Since line segment CD is perpendicular to line segment AB, then the degree measure of angle ADC is equal to the degree measure of angle CDB and is equal to the degree measure of angle ACB, which is 90 degrees. Then, by AA similarity theorem, we have the triangle ADC is similar to triangle ACB. Using the same theorem, and that angle B is congruent to angle B, we have triangle ACB is similar to triangle CDB. Hence, triangle ADC is similar to triangle CDB by transitivity. Recall that the geometric mean of two numbers A and B is the positive number x such that A is to x is equal to x is to b. If x is the geometric mean of A and B, then x is equal to the square root of A and B. In the figure, AD over CD is equal to CD over BD, and AB over AC is equal to AC over AD, and AB over BC is equal to BC over BD. Now, let's assume that line segment CD is the altitude to the hypotenuse line segment AB of right triangle ACB. If AD is equal to 3 and DB is equal to 12, let's find the measure of CD. So from here, our proportion that we're going to use is AD over CD is equal to CD over BD. And now, let's substitute the value. The value of our AD is 3 and the value of our BD is 12. And since we're looking for the value of CD, we don't need to substitute that. So we have now 3 over CD is equal to CD over 12. And again, we're going to apply the fundamental rule of proportion. So we have now CD times CD, we have CD squared. And 3 times 12 is we have 36. And after that, let's extract the root so that we find the value of CD. So we have square root of CD squared is equal to the square root of 36. So therefore, the value of our CD is equal to 6. Next, the same figure, if AD is equal to 6 and BD is equal to 18, let's find the value of AC. For this, the proportion that we're going to use is AB over AC is equal to AC over AD. And after that, let's substitute the value. So we're going to substitute the value of AB and AD. So therefore, the value of our AB is 24 because 18 plus 6 is equal to 24. And the value of our AD is 6. So therefore, we have now 24 over AC, since we're looking for the value of AC, and is it equal to AC over 6. Again, let's apply the fundamental rule of proportion. So AC times AC, we have AC squared. And 24 times 6, we have 144. And after that, let's extract the roots. So we have now square root of AC squared is equal to the square root of 144. So therefore, the value of our AC is equal to 12. Next, with the same figure, if AD is equal to 6 and BD is equal to 8, let's find the measure of BC. So for this, the proportion that we're going to use is AB over BC is equal to BC over BD. And now, let's substitute the value. So the value for our AB is 14 because 6 plus 8 is 14. And the value of our BD is 8. So therefore, we have 14 over BC is equal to BC over 8. Again, let's apply the fundamental rule of proportion. So for this, 14 times 8 is 112. And BC times BC is BC squared. And after this, let's extract the square root so that we can find the value only of BC. Since 112 is not a perfect square, we need to factor the 112, or which is our radicand, so that one of its factor is a perfect square. So the factor for 112 is 16 times 7. And among 16 and 7, 16 is a perfect square. So we're going to move out of the radical sign. So therefore, we have now 4 square root 4 and square root of 7. So therefore, the value of our BC is 4 and square root of 7. Now, let's proceed to the special right triangle theorem. The right triangles whose measures 45 by 45 by 90 degrees or 30 by 60 by 90 degrees are referred to as special right triangles. The Pythagorean theorem gives us information about the special right triangles. In the previous lesson, we proved that in a 45 by 45 by 90 degrees triangle or in an isosceles right triangle, the hypotenuse is the square root of 2 times as long as each leg. We proved also that in a 30 by 60 by 90 degrees triangles, the hypotenuse is twice as long as the shorter leg, and the longer leg is the square root of 3 times as long as the shorter leg. Now, let us apply the theorem. For our first example, triangle PRS is a 45 by 45 by 90 degrees triangle, and RS is equal to 16. So let's find PS. So from here, we will have our solution. Since we're looking for our PS, which is our hypotenuse, and the given side or the given measure of our side is RS, which is 16. So we can use PS is equal to RS and square root of 2. And we all know to get the hypotenuse is square root of 2 times as long as each leg. So therefore, PS is equal to 16 and square root of 2. So that is the value or the measure of our PS. Next, for our second example, using the same figure, if PS is equal to 12, let's find RS. So from here, we will have our solution. So we have, since we're looking for our RS, and the given here is our hypotenuse, which is 12. So to get the PS, or to get the RS, we all know that PS is equal to RS and times the square root of 2. Now, so let's substitute the value of our PS, which is our hypotenuse. So we have 12 is equal to RS and square root of 2. And after that, divide both sides by square root of 2 so that we can find only the value of RS. So divided by square root of 2 divided by square root of 2. So we're going to cancel the square root of 2 on the right side. And now, the remaining will be 12 over square root of 2. And that is not the final answer. Why? Because we need to rationalize our denominator. So we have RS is equal to 12 over square root of 2 times square root of 2 over square root of 2, which is to rationalize, and after that, we simplify. So therefore, we can get 12 and square root of 2 over square root of 4. So we will have 12 and square root of 2 over 2 because 4 is a perfect square. And after that, we can simplify or we can divide 12 over 2. So therefore, our RS is equal to S is equal to 6 and square root of 2. You need to remember that the legs of a 45 by 45 by 90 degrees triangle are the same. Next, the length of the hypotenuse of a 30 by 60 by 90 degrees triangle is 16. Let's find the length of the shorter leg and the longer leg. So let's draw the figure. So we have 16, which is our given, which is the hypotenuse. We have a 30 degrees angle, and the opposite side of 30 degrees is our shorter leg. So let's label it as side A. And we have also a 60 degrees angle, and the opposite side is our longer leg. So let's name it as side B. So now, since we need to find the shorter leg first, we will have 2A is equal to C. Why? Because we all know to get the shorter leg, the hypotenuse is twice as long as the shorter leg. So if we substitute the value, we have 2A is equal to 16, which is the value of our hypotenuse. And after that, we apply the multiplication property of equality. We multiply both sides by 1/2. So 2A times 1/2, we have 2a over 2. And 16 times 1/2, we have 16 over 2. So 2a divided by 2, we have 1a or 8. And 16 divided by 2 is 8. So therefore, our shorter leg is 8. Now, to get the side B or the longer leg, let's use B is equal to A times square root of 3. Why? Because we all know to get the longer leg, it is square root of 3 times as long as the shorter leg. So since our shorter leg is equal to 8, we substitute the value of A. So we have now B is equal to 8 and square root of 3. You need to remember that the opposite side of the 30 degrees angle is the shorter leg and the opposite side of the 60 degrees angle is the longer leg. And that is how you solve or apply theorems for similarity for triangles. Now, I hope you understand our lesson for today, which is applying the theorems to show that given triangles are similar. Thank you for watching.